Okay, so let's start the lesson for today, no? Like I said, medyo mahaba-haba to ng konti, ano. So this week we're going to be taking up network theorems. There are three theorems that we're going to take up. First is Thevenin and Norton equivalents. No, that's based on Thevenin's theorem and Norton's theorem. And then the third, which we will touch upon on next Thursday, is superposition. Okay. But before we do that, I want to discuss with you source transformation. Okay, ito yung situation ko, no? When can I replace this particular circuit on the left with this particular circuit on the right, no? So what I want to happen is I want to have this become equivalent to this, no? So ano sabi natin pag equivalent yung dalawa? Equivalent yung dalawa pag may kinabit ako rito, let's say I connect something here, let's call this X, and I connect the same thing here, connect X. From the point of view of X, hindi alam ni X kung ano yung nakakabit sa kanya, no? Kung equivalent yung dalawa, hindi alam ni X kung ito ba ang nakakabit sa kanya o ito ba yung nakakabit sa kanya, no? So yun yung gusto natin mangyari. Sorry. Okay? So how do we make the two equivalent, no? Dito sa left side, let me do a KVL, no? KVL. So this particular loop. So what is my KVL? My KVL is V sub S is equal to I times R plus V. No? This voltage is equal to this voltage, which is R times I, plus this voltage, which is V. Dito naman sa kanan, gagawa ako ng KCL dito. What is my KCL there? My KCL there is I sub S, okay, is equal to this current. But what is this current, no? The value of the voltage across my resistor is V. This voltage is across my resistor. So what is this current? This current is just V over R plus I. Okay? Now if I multiply both sides of this equation by R, what am I going to get? I'm going to get I sub S R is equal to V plus I times R. So remember, I want the left side and the right side to be the same. No? This is already the same, and therefore this must be equal to this. V sub S must be equal to I sub S times R. So ano ibig sabihin nun? Okay? If I want to change my voltage source to a current source, as long as I have a resistance that is in series with the voltage source, I can convert it to a current source in parallel with the same resistance, where the value of I sub S is equal to V sub S over R. On the other hand, if I have a current source and I have a resistor in parallel with the current source, I can change that to a voltage source where the value of V sub S is I sub S times R. Okay, in my earlier class, may nag-comment, ano, it looks like Ohm's law. Yes, it looks like Ohm's law, but there's something very different between this and Ohm's law. Remember that in Ohm's law, the voltage is across your resistor and the current is through your resistor. While the current here is through your resistor, the voltage is not across the resistor. So same thing here, no? The current is through the resistor, but the voltage is not across the resistor. So don't make the mistake of thinking of this as Ohm's law, because it looks like Ohm's law, but it is not Ohm's law. Anyway, ano yung kagandahan nito, no? This now gives me an additional weapon for solving problems using circuit simplification. So let me give you an example. So this is my example. Solve for the power associated with the 6-volt source. So I want to solve for this power, okay, and indicate whether the source is absorbing power or delivering power. So what is my strategy here? I want to solve for the power associated with this. So I want to compute for the current that it is supplying. Let me call this I of S, the current that this is supplying. So the power that will be delivered by the source would be equal to 6 volts multiplied by the value of I of S. That is the power that it will be delivering. Because remember, this is the reference polarity of current if this voltage source is delivering power. So what is my strategy? The strategy would be the remainder of the circuit, I convert to an equivalent circuit. Now before, you learned how to convert or simplify a circuit, you learned how to simplify a circuit kung resistive siya. Ngayon, hindi na siya resistive, no? Meron na siyang source dito. So this is a new weapon. How do you simplify a circuit when there is a source? And one way is by doing source interconversion. So if I want to compute for I of S, I have to preserve the branch. I have to preserve the branch where I of S is flowing. So I will simplify the rest of the circuit. So how do I go about that? You notice here, I have a 40 volt in series with a 5 ohm. So what can I replace this with? Ito. So I'm just outlining the strategy. I can replace this with a current source in parallel with the 5 ohm. What will be the value of my current source? Anyone? Just shout it out. What will be the value of my current source? I'm sorry, Peter, no? It's not 40 amperes. That's right, no? It's 8. This is going to be 8 amperes, right? It's going to be 40 divided by 5. So if I replace this now with my current source, what do I have? I have 5 ohms that is in parallel with the 20 ohms. Okay, so I can put the 5 and the 20 in parallel, no? Anyway, let's see, no? So ito 'yon, ano? Ito yung 8 at saka 5. So itong 20, nakaparallel ngayon yung 20 at saka 5. The parallel combination of 20 and 5, this is 4 ohms. And then I convert now this whole thing back to a voltage source. The value of my voltage source will be 8 times 4, which is 32. So ito yun, no? This is 8 times 4. And the value now of my resistance is this 4 ohms. No? So this is the second step. Now notice, this 6 ohms is now in series with this 4 ohms, which is also in series with this 10 ohms. In my earlier class, tinanong, no? Naka-series ba itong tatlong to, no? Itong 6, itong 4, at saka itong 10. When you have elements in series like this, you can change the order of the elements in the branch, and that's not going to affect the rest of the circuit. Because when you apply KVL inside here, it doesn't matter what the order of the elements are, you're going to get the same KVL equation. So ito, at saka ito, I just get the sum, and that is equal to 20 ohms. No? The sum is equal to 20 ohms. Right? So now I can convert this whole thing into a current source. So what is the value of the current source? 32 divided by 20, that's 1.6. So this is 32 divided by 20. And then this 20 ohms is just now in parallel. And so now I have 30 ohms in parallel with 20 ohms. This is 12. I convert this again to a voltage source. So this is what comes out. And finally, this is just now 1 KVL loop. What is my KVL equation here? My KVL equation is minus 6, okay, plus IS times 4, plus IS times 12, plus 19.2 is equal to 0. And so IS can easily be computed. Note that it is negative in value, meaning to say the actual direction of current is this way. So it's absorbing instead of delivering, it's absorbing. And the amount of power that it is absorbing is 4.95 watts. Now that's 6 volts multiplied by 0.825 amperes. Any questions? Any questions? Okay, I want to point out to you something that is worth noting. Whenever you have a resistor in parallel with an ideal voltage source, this resistor is not going to affect anything that is connected to terminals A and B. So our R's of P will not have an effect on what is connected to A and B. Why is that so? Because regardless of the value of this resistance, whether that resistance be very small or that resistance be very large, the voltage across it will always be constant at V sub X. So it could have been equal to infinity. That is, it could have been an open circuit, and the value across it will still be equal to V sub X. Okay, you have a similar situation with a current source. Whenever I have a resistance that is in series with an ideal current source, this current source, R sub S, will not have an effect on what is connected to A and B. So same here for R sub S. Okay. In other words, if I replace this with a short circuit, there will be no effect on what is connected across A and B. So for both cases, R's of P or R's of S can be removed. In this case, removed by replacing it with an open circuit. In this case, removed by replacing it with a short circuit, since they have no effect on the equivalent circuit that predicts behavior with respect to terminals A and B. So I'm going to give you another example here. So in this example, solve for V sub O by simplifying the circuit using source transformation. So this is what I want to compute for. I want to compute for V sub O. Now remember our rule. If I want to compute for V sub O, I must make sure that the terminals across which V sub O is measured or is determined is preserved. In other words, if I simplify the circuit, I can simplify the rest of the circuit basta yung terminals kung saan naka-indicate yung V sub O dapat hindi mawawala. Now to simplify the circuit, since we're determining V sub O, itong 125 ohms, which is directly across an ideal voltage source, will not have an effect on V sub O. So you can remove it. Tsaka itong 10 ohms, which is in series with your ideal current source, will not have an effect on V sub O, and therefore you can replace it with a short. So ito yung original circuit natin. Ito ngayon yung simplified circuit. Tinanggal natin yung 125 ohms at saka tinanggal natin yung 10 ohms. And then I convert this to a current source. So this part, I converted to this. And then notice now, I can combine the 10 ampere and the 8 ampere into a single current source. That's 2 amperes. Remember our sources in parallel. And then I can combine the 25 ohms, the 100 ohms, and the 20 ohms into a single resistor. By doing so, I am not eliminating the terminals across which V sub O is determined. No? So I can do this. I can convert this into one single resistor kasi nandun pa rin naman yung terminals across which V sub O is determined. So note how much simpler my circuit is now. And so my V sub O is just equal to 2 amperes. V sub O is 2 times 10 ohms, which is 20 volts. Okay, now just a warning, no? This and this does not have an effect on V sub O, but they have an effect on the power that are being delivered by your sources. So if the problem here is determine the power, for example, being delivered by this voltage source, hindi mo pwedeng tanggalin to. You cannot take that out, no? Because that affects the current that this is delivering. So ang sinasabi ko lang dito, you can take this out or you can take this out if you are determining something that is apart from that. Okay. Anyway, that's all I wanted to warn you about. So I hope this is clear. Any questions? Any questions with regard to this?
Sir,
Yes.
may question. Sa voltage lang po siya, sir, applicable. So pag hinahanap lang po yung voltage, doon lang po kami pwedeng mag-eliminate ng mga resistors kapag pwede po. Pagka voltage lang po yung hinahanap. Or
Kapag voltage or current na nasa labas ng terminals ng current source or voltage source. Parang balik tayo dito sa ano, no? Kapag ang hinahanap mo, for example, in this particular circuit, ano, kapag ang hinahanap mo is a voltage or current in this circuit na nandito, pwede mong tanggalin to. Okay? So, dito rin, no? Kung may nakakabit dito, ang hinahanap mo is a voltage or current inside here, pwede mong tanggalin to.
Okay, sir. Gets na po.
Okay?
Thank you.
Yun ang, so, gaya dito sa example na to, ang hinahanap mo is nasa labas nito, di ba? Nasa labas nito, at saka nasa labas din nito. So, nasa labas nito ang dalawa. Ibig sabihin, pwede mong tanggalin to, at saka pwede mong tanggalin to. So, yun yung parang pinaka-guide mo. Okay, so let's go to what I really wanted to discuss today, which is Thevenin's theorem. Okay, ano yung Thevenin's theorem? No? This is a very important theorem na time and time again you're going to encounter in your EE, and you're going to see how useful it is. Let's say you have a big circuit, and you can partition that into two circuits which are connected to each other. So in this case, meron tayong malaking circuit, and I can separate that into two circuits. I'll call the left side network A, the right side network B, connected together through terminals X and Y. Now, sinasabi ko rito, A is a linear circuit, B may or may not be linear. Don't worry too much about the definition of what a linear circuit is. You're going to take that up later on, no? Especially in your future courses. But I want to guarantee you now that all the circuits that you've been dealing with so far, yung mga resistive circuits na kinuha natin so far, those are linear circuits. No, that's all that I want to tell you right now. So, wag kayong masyadong mag-worry na ano ba ang ibig sabihin ng linear circuit. You'll take that up in due time. Okay, now assume that the dependent sources in A, if there are any, are controlled by currents or voltages within A, and the same for B. No? In other words, kung meron akong dependent source sa loob nito, let's say I have a dependent source here, sabihin natin plus minus, uh, let's say K IX. No? Itong IX na to, dapat nasa loob nito. Hindi pwedeng yung IX nandito. Yun ang ibig sabihin nitong statement na to, no? That dependent sources in A, if any, are controlled by currents or voltages within A. Ito, bawal to. Bawal yan. No? So the dependent sources in A, dapat voltages or currents within A. Ganun din dito. Dependent sources in B, controlled by currents and voltages within B. Ano ang sinasabi ng Thevenin's theorem? Oh, by the way, no? Before going to Thevenin's theorem, itong network B, typically, this can be thought of as the load of network A. That's usually how we partition circuits. The left side network A might be your source, and the right side network B might be your load. That's a very typical way of partitioning circuits. Network A, according to Thevenin's theorem, can be replaced by a voltage source, VTH. We call that the Thevenin voltage, in series with a resistor, RTH, which we call the Thevenin resistance. The voltage source in series with the resistor is called your Thevenin equivalent of network A. In other words, I can redraw this now in the following manner. Ito yung Thevenin equivalent ng network A ko. So ito yung load ko na nakakabit. And this now, we do this now to simplify any computations we want to do within the load. So ito pampadali ng computation dito sa network B. We simplified network A. So again, this is another network simplification tool where the network you are simplifying contains sources. So madami na tayong natututunang network simplification tools. No? One is resistances in series and parallel. One is sources in series, sources in parallel. The other is voltage source, current source conversion, which we just studied a while ago. And this now is getting the Thevenin equivalent. That is a network simplification tool. Now, what is the value of VTH? VTH is the open circuit voltage from terminal X to terminal Y with network B removed. Okay? So, if this is network A, sabihin natin this is network A, let me just label it A, no? Network A, this is X and Y. If I get a voltmeter and I measure this voltage, VXY, this is actually VTH. Kung magkabit ako dito ng voltmeter, ano? I don't know whether you've ever used a voltmeter. And then you measure this value, that is actually VTH. Okay. Now, if network A contains only independent sources, so sabi natin, no, network A can contain both independent and dependent sources. And the only restriction we gave was that if it contains dependent sources, dapat controlled within network A. Now, for the case when network A contains only independent sources, RTH is the equivalent resistance looking into terminals X and Y with all independent sources reduced to zero. All independent sources reduced to zero. Now, how do you reduce an independent source to 0? Another way of saying this is suppressing the source. Suppressing the source. So if it's a voltage source, you replace with a short circuit. If it is a current source, you replace with an open circuit. That's how you suppress sources. Now, for example, I'll give an example. Let's say I have this circuit, V1, say V2, then let's say I1, and then let's say R1, R2, R3. Okay. If I suppress my sources, what is my circuit? Yung V1 ko becomes a short circuit, so I have R1. Yung V2 ko becomes a short circuit, then I have R2, then I have R3, and then yung I1 ko becomes an open circuit. So this is I1. So this is now my circuit with the sources suppressed. So again, if it's a voltage source, you replace with a short circuit. If it's a current source, you replace with an open circuit. That's how you suppress your sources. So that is Thevenin's equivalent. Now, Norton's theorem is very similar. So these are the same conditions as your Thevenin's theorem. This is your load. Anong sinasabi ng Norton's theorem? Itong network A can be replaced by a current source I sub n, which we call our Norton current, in parallel with a resistor R sub n, which we call our Norton resistance. So this is called the Norton equivalent of network A. So I can redraw this. This way. So your network A is now replaced by my Norton equivalent. So with network B connected, it is now easier for me to compute for the values that we want to compute for within network B. So that is what we want to use Norton's theorem for. Now, what is the value of I sub n? I sub n is the short circuit current from terminal X to terminal Y with network B removed. So in other words, if this is network A, this is X and this is Y, what will I do? I will short this. I will short that. Kukunin ko yung IXY, that is the current that will flow in my short, that is equal to I sub n. So yan yung magiging value nitong I sub n. And R sub n, excuse me, R sub n is going to be the same as RTH. So R sub n is the equivalent resistance from terminal X to terminal Y looking into network A with all independent sources reduced to 0. Let's take an example. So in this example, determine the equivalent circuit, determine the Thevenin equivalent circuit of the following circuit with respect to terminals A and B. So ang assumption dito is the load has been removed, ano? In this particular case, the load is already removed. And I want to get the Thevenin equivalent of this particular circuit with respect to terminals A and B. Okay. So how do I get my Thevenin voltage, VTH? I measure or I compute for VAB open circuit voltage, meaning walang nakakabit dito, no? Open circuit voltage, walang nakakabit dyan. And that should be equal to VTH. Okay, kung walang nakakabit dito, ano ang value ng current na dumadaan sa R2? Can somebody shout out the answer? If there's nothing connected to A and B, what is the value of the current flowing through R2?
0 po, sir.
Yeah, that's right, 0, no? Kasi open circuit. Okay? Therefore, ano yung voltage across R2? The voltage across R2 will also be equal to 0 because you have no current, so you have no voltage. So if this is my voltage across R3, VR3 will be equal to VAB, which is just VTH. Yung voltage here and the voltage here will be the same because there is no current flowing here and therefore there's no voltage here. Pag nag-KVL ako rito sa loop na to, I'm going to get VR3 is equal to VAB or VTH. But what is VR3? VR3, by voltage division, because now this and this are in series. Baka magtanong kayo, sir, hindi nakaseries yan dahil may nakakabit dito? Meron yung nakakabit dito, pero open circuit naman siya. In other words, this is hanging. If this is hanging, then effectively, there's nothing really connected here. Because even if this is connected, no current can flow through it. So effectively, there's nothing connected here. That places this and this in series. So VR3 using voltage division, voltage divider, okay, is equal to 30 volts multiplied by R3 over R1 plus R3. Notice that R1 and R3 are equal. So when they're equal, the voltage 30 volts will just split between R1 and R3. So this is going to be equal to 15 volts. Okay. Yan yung Thevenin voltage natin. So VTH is equal to 15 volts. Okay, what is our Thevenin resistance? So unang-una, we get the equivalent circuit of this with our independent sources suppressed. So how do you suppress a voltage source? You replace it with a short circuit. So this circuit with the sources suppressed will look like this, ano? Ito yung 30 volt source na naging short circuit na. Then meron akong 10K. Meron akong 10K. Meron akong 10K. And I am now looking at RAB. What is the value of RAB? Anyone? Very, very quickly.
15 po.
Yung mga, ano?
15 po. 15K.
Yeah, that's right. Ano? Yun yung mga tipong quiz sa UVLE, no? Bibigay sa iyo ng circuit and you're expected to be able to answer it in 1 minute. Because what is RAB? RAB is just 10K in parallel with 10K plus 10K. So this is just 15K. No? Recognize that these two are in parallel, and then that's in series with this. So that's 15K. So finally, what is my Thevenin equivalent? I just have 15 volts in series with 15K. This is A and this is B. This is my Thevenin equivalent now. So, in other words, with respect to A and B, whether I put this circuit or whether I put this circuit, yung kinakabitan ko hindi malalaman what the difference between the two are. That is the essence of equivalence. Any questions? Any questions? Again, no? It's a way of getting an equivalent circuit for this with respect to terminals A and B that is very simple. Okay, now supposing the problem had been determine the Norton equivalent. Determine the Norton equivalent. No? Let's say hindi natin alam kung ano yung Thevenin equivalent. Let's say ang gusto nating binigay sa atin tong circuit na to, no? Binigay sa atin tong circuit na to, and pinapakuha sa atin yung Norton equivalent. Okay, so what do I have to do? What do I have to do? To get I's of n, I short this two together, and I's of b, IAB, which will flow, let's say this current that will flow, that is equal to I's of n, my Norton current. How do you solve for IAB? Okay? Madami na kayong techniques na lalalaman para dyan. Ano? When all else fails, this is what I suggest to you. No? When all else fails, go back to your node voltage method or nodal analysis. Because you have so many ways of computing for IAB, but if you don't know where to start, no, just go back to nodal analysis. How do we do nodal analysis here? We can get, for example, this voltage V of X. No? We can solve for V of X. So what is our nodal equation with respect to X? Okay, your V of X minus 30 divided by 10K. Okay, that's this current, no, pag ganyan. Okay, plus V of X over 10K. So ito naman yung current pababa. Okay, plus V of X over 10K. Ito naman yung current dito. This is equal to 0. Okay, and so you can solve for V of X. Okay, ano nga ba yung value? Okay, let's do it. Ano? So V of X, 1 over 10 plus 1 over 10 plus 1 over 10 is equal to 30 over 10. No? So 3Vx is equal to 30. So V of X is just equal to 10 volts. V of X is equal to 10 volts. Okay. What is IN? IN is just V of X over 10K. Because what is the voltage across this resistor? The voltage across this resistor is V of X because this is shorted. So what is this? No? This is 10 volts over 10K. So this is equal to 1 MA. So yun yung value ng I of n, 1 MA. Tapos yung value ng Rs of n, na-solve na natin kanina, no? Yung value ng Rs of n is the same as your Thevenin resistance, Rs of n, is equal to 15K. So what is my Norton equivalent? I have 1 MA, okay, in parallel with 15K. And this is A and this is B. So this is now my Norton equivalent. Again, no? Whether it is this circuit connected to something or this circuit connected to something, that something will not be able to tell the difference. Note that if I already know the Thevenin equivalent, kung ito nalalaman ko na, madaling kunin yung Norton equivalent. You just use voltage source to current source conversion. So yun yung una natin pinag-aralan today. No? How do I convert this to this? My current source is my voltage source divided by my resistance. So that gave me 1 MA. And then the resistance is the same, 15K there, 15K here. On the other hand, if I knew my Norton equivalent, to get the Thevenin equivalent, I just multiply 1 MA by 15K to give me 15 volts. And then the 15K is placed in series. Any questions? So, again, no, kung alam na nyo yung Thevenin equivalent, it's easy to get the Norton equivalent and vice versa. Circuit analysis using Thevenin equivalent. So this is the general procedure for circuit analysis using Thevenin equivalent. First is to remove the load. So kung meron tayong circuit, unang-una tanggalin natin yung load, which is, we describe that as network B. And then you get the Thevenin equivalent of the remaining network with respect to the load terminals. After you've gotten the Thevenin equivalent, so ito na yung Thevenin equivalent natin, ibalik natin yung load, reconnect the load. And now it should be easy to obtain whatever quantity we desire within the load. So our presumption is there's a quantity within the load that we want to determine. Dapat madali na i-compute yun. So let's take this example. Use Thevenin's theorem to find I of x, the current through the 20 ohm resistor. So what is going to be my strategy here? So I can consider this to be my load. Consider the 20 ohms to be the load. So tatanggalin ko siya. Tatanggalin ko siya. Okay, let me call this X and Y. Point X and point Y. So tinanggal ko yung 20 ohms. With respect now to X and Y, I want to simplify this particular circuit. I want it to be just a voltage source in series with a resistance. So how do I do that? First, I compute for VTH, which is the open circuit voltage between X and Y. How do I compute for VTH? Well, it's really quite simple for this particular example. If I do a KVL here, let's say I do a KVL here, let's call this voltage V of X, and let's call this voltage V of Y, with the polarities as shown. So kung magti-KVL ako rito, KVL, what am I going to get? I'm going to get, okay, negative to positive is negative, so minus Vx, plus to minus is plus, so plus VTH, the negative to positive is negative, so minus Vy is equal to 0. So this is just VTH is equal to V of X plus V of Y. Now, what is V of X? Ano itong value ng V of X? Okay, since this is open, then this is just in series with this. And I can now use voltage divider. No? So V of X is just 27 multiplied by 4 over 4 plus 1. Okay, so that's 27 multiplied by 4/5. That is 21.6 volts. This is 21.6 volts. Ano naman tong V of Y, no? Now, why did I assign this polarity to V of Y? Because this 6 ampere current is just flowing in this resistor in the upward direction. So yung current dito, paikot lang na ganon, ano? Walang current na pupunta dito dahil open circuit to, no? Walang return path yung current. Therefore, all of this current will just be circulating here. And V of Y is simply 6 times 5, no? 6 times 5, which is equal to 30. Meaning to say VTH is 30 plus 21.6. This is 51.6 volts. Yun yung VTH. Now, how do I get RTH? RTH is the resistance looking into XY with my sources suppressed. So what is my circuit going to look like with my sources suppressed? Okay, ito yung voltage source ko. No? Naka-short na yan. I have 1 ohms. I have 4 ohms here. This is X. This is Y. This is 5 ohms. And this is my 6 ampere. No? So ito open, ito short. Okay, what is RTH? By inspection. Ano yung RTH? Anyone? Anyone? Just shout it out. Ano yung value ng RTH? Are you awake? RTH, no? That's this, no? RTH. Looking into X and Y.
Sir,
So mula,
5.8 po ba?
that's right, no? 5.8. No? 5.8 ohms. Bakit, no? You have 1 ohm in parallel with 4 ohms, which is 0.8 ohms, that is in series with the 5 ohms. So that's 5.8 ohms. Okay. So, anong ibig sabihin nun, no? Oh, by the way, ito pala yan, no? 5 times, so this is 5.8 ohms, no? Okay, so ito na yung RTH. So ito na yung Thevenin equivalent. Anong gagawin natin ngayon? Remember what we wanted to do was we wanted to compute for the current going through our load. So ibalik natin yung load. So you put the load back. Put the load back. Okay, ang dali na ngayon i-compute yung load current. No? My load current is just 51.6 volts divided by 5.8 plus 20. Okay. Which is exactly equal to 2 amperes. Any questions? Ito pala, no? The answer is here. Okay, what if you wanted to do this using Norton equivalent? No, so remember, no, we didn't do. Let's say we wanted to do this from the get-go. You wanted to use Norton's theorem or Norton's equivalent. So the procedure is very simple. You remove the load. You determine the Norton equivalent circuit of the remaining network with respect to the load terminals. You reconnect the load. So this is your Norton equivalent now. You reconnect the load. And then it should now be easier to compute for your load conditions. So same example. Use Norton's theorem to find Ix, the current through the 20 ohm resistor. So ano yung unang gagawin natin? We consider this to be the load. We take it out. Okay? We take it out. And we compute now for this particular current. Kasi pag tinanggal natin to, okay, we now want to get the Norton current, so we short, no? So remember, this is X, this is X, this is Y. You short it. And then kung ano man yung current na dadaan dun sa short na yon, that would be your Norton current. How do you compute for Is of n? Again, like I said, no? When all else fails, try nodal analysis, which is actually the solution that that these nodes make use of, no? So this is one node, no? Remember, this is one node. Isa lang yung node natin. Our objective here is to compute for V's of A. So how do you compute for V's of A? You apply KCL to this particular node. Okay, KCL tayo dito. So what's my KCL equation? This current, pag ganito, no? The current here in this direction will be V's of A minus 27 over 1. The current here downward is V's of A over 4. The current here downward is V's of A over 5. Okay. The current here going out is 6. So plus 6, that's all equal to 0. And if you solve for this, you get V's of A is equal to 14.48 volts. One equation lang yan, one unknown. So knowing V's of A, how do we get Is of n? Okay, if this is V's of A, remember that this is also V's of A. No? That's also V's of A. So what is this current? Let's call this, let me just call this I1, no? I1. I1 is equal to 27 minus V's of A over 1. And let's call this I2. I2 is just V's of A over 4. So what is IN? IN is just I1 minus I2. No? Because I2 plus IN should be equal to I1. Okay, and if you do that, you're going to get 8.9, no? 8.9 amperes. Okay. Actually, another way na mas obvious pala, no? Is you can do a KCL here, no? Yung gaya ng ginawa rito, no? Ang ginawa naman niya is Is of n is this current minus this current. So itong current na to is just 6. Itong current na to is just V's of A over 5. That's an easier way, no? That's an easier way of doing it. So yung RTH, alam na natin dati. Okay. So this is now my Norton equivalent. I just replace my load, and I can now use current divider. So this is your current divider formula. To determine Is of X. Is of X is 8.9 multiplied by 5.8 divided by 5.8 plus 20. Any questions? Something in addition to, well, something that you have to remember. The method that we use to determine RTH assumes that network A, you remember yung network A natin kanina, contains only independent sources. Walang dependent sources. So yun yung sinasabi rito. So yung ginawa nating method na, okay, you get the equivalent circuit, you reduce all independent sources to zero, then you get the equivalent circuit with respect to the load terminals. That can only apply if network A contains only independent sources. What will happen if network A has both independent and dependent? By the way, no, I have some examples here. No, so try this out on your own. No? So circuits with independent sources only. So here the problem is find the voltage V sub O using Thevenin's theorem. No? Using Thevenin's theorem, find the voltage V sub O. So this is only independent sources. No, this is independent and this is independent. So you can do this using Thevenin's theorem, and you also can try to do this using Norton's theorem. So those are just exercises. Now, what if the network contains both independent and dependent sources? So we're talking about network A. So there's a different procedure now for determining RTH. So this is the procedure for determining RTH. You remove the load, you get the open circuit voltage across the load terminals, and then you connect a short between the load terminals and you measure the short circuit current, and RTH is the ratio of the open circuit voltage and the short circuit current. Okay, this is where I'm going to start next week. No, not next week, next Thursday. No, I'm going to give an example for this. I think you probably have heard enough to chew on for today, so I'm going to stop. I'm going to stop here. So are there any questions with respect to what we took up today? In summary, what did we take up today? We took up source conversion, then we took up Thevenin's theorem, and we took up Norton's theorem, but we limited it to networks which contained only independent sources. So ang kukunin natin on Tuesday is what if it contains dependent sources, and then finally, what if it contains just dependent sources, no, walang independent sources. And then on Tuesday, we're also going to take up superposition. Any questions? Okay, I have an announcement. No? These notes that I'm showing you, this lecture that I'm giving to you, is not the official material for this week's lectures. The official material for this week's lectures was prepared by Dr. Ramos. He already published this in UVLE. If you take a look in UVLE, dun sa portion Thevenin and Norton, and also later on superposition, under supplementary lectures and videos, dun nakapublish yung official material. No? I took a look at the official material. It's easy enough for you to understand, so please go through it. So this lecture that I'm giving you, I just recycled this from old lecture slides that I came across. So parang supplementary lang to. No? I'm going to publish this. Excuse me. I'm going to publish this for you, but this is supplementary. Like I said, this is not the official material. The official material, please take a look at UVLE for the official material. Okay? Any questions again before I let you go? Yes.
Good day po, sir. Ulit. Yung question ko po, regarding po listen sa problem set po sa vector. Hindi ko po kasi siya mahanap po sa UVLE. So,
Hindi mo mahanap?
opo, I mean, yung nakakita ko lang po dito is yung quiz 1 and quiz 2 po ng nodal analysis.
Okay. Nasa announcement siya. Sorry, ano? Nasa announcement siya.
Okay po, sige po.
Okay.
Salamat po,
Siguro ilalagay ko sa ano, no? Just like the last time, no? Yung problem set for last week, which is actually dapat June na yun, di ba? Yeah, that was due, I think, yes, last Sunday, no? I also posted it through the announcements. Hanapin mo sa announcements.
Okay na po, sir. Nahanap na po.
Okay.
Salamat
sige.
po, sir.
Any other questions? Parang pakaunti ng pakaunti yung nag-attend ng mga lectures na to, no? Hopefully that's not a sign of people not getting anything out of it, no? But anyway, I guess I cannot force you to attend because really these are supposed to be optional synchronous sessions that we're holding. So if there are no more questions, I guess that's all for today. No, so thank you. See you again on Thursday.